Next topic is pattern-oriented alerting, and it is a machine learning-based alerting model. What I mean by machine learning, it means that we are also able to predict the probability of such an event to occur. And what I mean by pattern-oriented, it means that algorithm is able to predict a certain behavioral pattern of the performance counter over time. And this is exactly where I pointed out to earlier on with the more simpler proactive alerting mechanisms, that how we are able to predict the exact momentum of the performance counter. So what is a pattern? The simplest way to understand a pattern is maybe an example where we are looking for a CPU peaking utilization on a server level over time. And when we are having a 2-minute time interval there, we see that how this CPU is behaving. It's behaving, first it goes to 20%, next 2 minutes it goes to 60%, next 2 minutes it goes back to 20%, and next 2 minutes to 60%, 20%, 60%, 20, 60, and so on. So it's zigzagging in between of 20 and 60%, and it does always that. So in such case, we can say that, okay, with 100% probability, we are having a 60% CPU utilization every another hour, every another 2 minutes, and 20% CPU utilization on every first 2 minutes. And this is the most simplest pattern that you would basically imagine. Okay, some jokester would say that, okay, the simplest pattern is flatline 0. That's true as well. But it's easier to understand what I mean by pattern with this example. So now pattern-oriented alerting is not only telling you that what is the probability of a certain pattern to occur, but also when a certain threshold point is exceeded in your alerting. So these both sides of the coin are filled, and it's exact information there. And of course, this gives you some constraints. It gives you one constraint that you need to have the most detailed log data available for your alerts, at least from 1 month of time, to be able to understand that which are the patterns that occur there. And the good news is that you don't have to understand those patterns. It's the pattern-oriented alerting mechanism that understands and trains those result sets and finds out that, okay, these are the most seen patterns in your data over time, and these are the probabilities for these patterns to occur with these exceedings of your threshold level you want to give for the performance counter. So the simple reactive monitoring tells you that, okay, you may have the rule that, okay, every time my server exceeds 60% of peaking CPU utilization, I will give an alert. So you can use that same alert level, threshold level, for this pattern-oriented alerting as an input parameter. So you get same alerting levels out from this pattern-oriented alerting equation. So how do you train the pattern-oriented alerting data? It's simple. It means basically just that you need this monitoring data. And when you have this monitoring data of at least 1 month, you can train the result set, and then this training is happening there automatically, and you can even retrain the result sets for next month and next month, so on, in order to improve the accuracy of the forecast and keep it up to date. So that is how simple it is. And what are the pros of pattern-oriented alerting? The pros are that you're able to find the hidden patterns and to predict the future. And also you can improve your forecast accuracy over time. The cons are that it may give you sometimes false alert. For example, the pattern-oriented alerting looks your data and it sees that there is always this kind of first little low trending pattern, then there's a little peak that goes down again, then a little straight line, then a high peak, very high peak. For example, 80% CPU utilization that would raise an alert, and then it goes very fast down. And this same pattern occurs very often in your data, but not that often that you're able to see that on bare eye and look all the 2-minute time points in your monthly data. But this algorithm can say you that, okay, within next 30 minutes, you get an alert that is peaking on 80%, and the pattern actually looks like this before it hits that ceiling, and then it continues like this. So now you have 30-minute interval of time. You have 30 minutes of time to react this certain alert and check out the plan cache, to start the tracing of TSQL, to check the weight stats, how that's distributed, and look for the query problem, or if it's an indexing problem, or what's problem behind, and fix that at its best even before that the problem will occur. At least you get the time to be ready to really drill down into this root cause of that problem before it even occurs. So therefore, you're getting better uptime, better service levels with very, very sophisticated alerting mechanism. But why it gives sometimes false alerts, what was the actual question there on cons, is that, for example, if the forecast says that with 85% probability you get an alert of 80% threshold level in next 30 minutes, it means that the rest 15%, which is 1 time out of 6.67, which means 3 times out of 20 times, it will give you a false alert. But that's quite small price to pay from this alerting mechanism, because it also tells you what is the probability to have that event to occur.